So who can read this first example problem to me and the answer? What would we say for that, right?
The square root of 36 equals 6.
Good. And what about the next one, Jack?
The square root of 89 equals 9, or 81 equals 9.
Good. And the last one there? Turn your brains on if they're off. Ellie?
30.
Good. The square root of 900 is 30. So basically, what number times itself gives you that number under the radical sign? That's what we're looking for. We can also use the idea to solve these simple little equations like this: a squared equals 49. If I know a squared is 49, what can I do to figure out what a is? I can get a. Peyton?
Divided by 2.
Well,
Yeah.
wait,
No, yeah. No.
because that would be like 20.
Oh, and find the square root of 49.
Yeah, take the square root of, squaring and square rooting are inverses of each other. So, Peyton, you're right, we take the square root of 49,
Which is 7.
which is 7. Now, remember, we can check if something's a solution by putting it back in and making sure it makes the statement true. 7 squared is 49, so 7 is a solution. But there's another solution, too. Actually, another solution. And I'm not going crazy. Nathan? -7, right? -7 squared would also give us 49. So we really technically would have a positive or negative square root of 49, positive or negative. Write them one under the other with a little space between them tells us that it could be either positive or negative 7. What about the equation a squared equals 144? What do we do to find a there? What do you think? Jillian? Yeah, and it could be positive or negative square root of 144. And what is the square root of 144? Katie? 12. Good. All right. Although every positive number, like 49 and 144, has 2 roots, one positive and one negative, we will only be using the, which one do you think? Right? Positive one for now. Because with the Pythagorean theorem, we're going to be finding distances. And what did we say about distance? Distance is always what, Ben?
Distance is always
Positive, yeah. Remember, if I ask you how far you live from school and you live in that direction, you just tell me 2 miles. And if you live in that direction, you just tell me 18 miles. You don't give me a sign or distance. So for that reason, the application we're using, we're just going to look at the positive roots. But you should know and understand that both of these roots are solutions to that equation. All right? Any questions about that? Ready to get to the work of today?
Wait, can I quickly finish typing in?
Absolutely.
Thank you. Alright.
All right, so what's different about this one? Square root of 50. Carolyn?
It's multiple of 10.
It's multiple of 10, that's true. Yeah. What makes it a little problematic? Jack?
It wouldn't, the square root of 50 isn't a whole number.
Yeah, nice wording. There is a square root of 50, but unlike all the other examples we've looked at, it's not a whole number. 7 times 7 is 49, so, and 8 times 8 is 64. It falls somewhere between them, right? It's not a whole number. If we do the square root, we'll find a crazy decimal number, which is also called an irrational square root. Crazy decimal that just keeps on going, non-repeating, non-terminating, kind of like pi, but it's a root. So we got to deal with that and kind of be thinking about what these numbers actually mean. Best way we can do it is we're going to learn how to estimate an answer to the nearest tenth. estimation technique. All right, so to practice, we're going to try to estimate the square root of 95 to the nearest tenth. All right. Well, anyone want to make a ballpark guess? Just for funsies? Peyton, that's good. You're always thinking.
10 maybe, is kind of close.
It's kind of close. Is it going to be more or less than 10, Peyton?
More,
How come?
because 10 times 10 is 100.
So the square root of 100 is 10, right?
Yeah.
So the square root of 95, what would you predict it would be? 9 something, right? 9 what? Give me a 9 point something.
9.7.
9.7 is Peyton's prediction. Let's see how close it ends up being. All right. So the way you start this process is kind of just like the dialogue that Peyton and I had. You think about the number, the perfect square on both sides of the number we're looking for an estimate for. So we want to figure out the perfect square that's below 95 and the one that's above it, and then we can estimate from there. What perfect square, what's the nearest perfect square below 95? Less than 95. Hold on. You guys know what I'm talking about here. Elkie?
No.
9 squared, which is 81. You got 81 is the perfect square below it. Square root of that is 9. And the one above it, Peyton already said, was 100. Square root of 100 is 10. So 95 falls between there, so I'm going to know it's 9 point something. All right? Well, we want to get good at predicting the point what. All right? So what we do is we kind of think of these numbers like they're on a number line. I haven't pressed pause. Alright, so we want to think of these numbers 81, 95, and 100 like they're on a number line, and we want to find out basically about how far 95 is between them. So we're going to write a fraction that shows that. Alright, so our step 2 is to write a fraction of how far 95 is between those two perfect square numbers. I'm going to pause for a second while you write that down. Okay, so we got to figure out, this answer is 9 point something, and we're trying to figure out 9 point what would be a good estimate. So basically, you want to find out how far are 81 and 95 apart. Like if they're on a number line, how many units are 81 and 95 apart from each other? How many places on the number line are they apart? Brian?
14.
14. If you didn't know that, you just do 95 minus 81 equals 14. They're 14 units apart. Out of altogether, how many units apart are 81 and 100? Brian?
19.
19. If you didn't know that, you just go over there and you do the subtraction. And you find out altogether, there's 19 units between those. So we can say that the square root of 95 is 9 and 14 19ths. 14 19ths of the way between 81 and 100. Okay, now this is where you got it. If you don't get that, you want to stop. You get wow, how we got 14 19ths. Because 14 is the distance between 81 and 95, and 19 is the distance all the way between them. Now that's a really ugly fraction, and what's cool about this lesson to me is that this is a good chance for you to practice your fraction decimal knowledge and conversions. We don't have 14 19ths memorized, but what's 14 19ths close to, very close to, that we can say, well, it's about, what's a friendlier one, right?
3/4. Or 15 20.
What's it?
15 20.
15 20ths, okay? So Ray says that this is pretty close to 9 and 15 20ths, right? Somebody else might have said 14 20ths. That's okay too. 15 20ths is what as a reduced fraction? Lauren? 3/4, which is what as a decimal, Lauren? 7/5. So this is about like 9.75, so we want this rounded to the nearest tenth. So we would say, what, Erin? 9.8 is our prediction. We're thinking that the square root of 95 is approximately 9.8. Now, you might approximate it slightly different, and that's okay. We just want you to be within 1/10 of what the calculator says. All right? So, let's find out what the calculator says. You have your calculator, which you should, pull it out of your bag. If you don't, you can't have one from me or borrow one. You can just look at your names who has theirs. First.
That would be.
Oh, yeah. I don't know how much recess time you'll get because lunch is 30 minutes. It's hard to tell.
I don't think we give reasons.
All right. So Jillian, I forgot to pull out step 3, which we just did. It's change that fraction to an approximate decimal. Okay. And now what we're going to do is we're going to talk about how you do this on a calculator. Okay. So for your homework, you're going to go through this process, and then you're going to check them on the calculator. Here's how you do it. Look at your calculator. Look at the left-hand side of buttons, and you should find the x squared button. You all see that?
Yes.
Above that, in the different colored print, is the square root button. See that? That means it's a second function key. So in order to get it, the square root of 95, you want to press the second function key first. The square button second, because we're taking the square root, the second function of the square button. Enter the number we're interested in, and press enter. And you'll get a decimal, but you're just rounding it to the nearest tenth. When you do, what do you get? Hold on.
9.7.
9.7.
Yay.
Good job, baby. Use your calculator.
This is good. This is a full credit answer because it's a tenth of what the calculator says.
Hoorah.
Okay? Did all of you who are working on your calculator find out how to get the square root there? Any problems? Brian?
Yes.
Okay. Process now. Alright, so let's try it on this problem. It's square root of 12. Square root of 12. We're approximating. Oops. Alright. So, what's the first thing you gotta look for if you're trying to get an approximation for the square root of 12? Lauren?
The square root above it and below it.
Good. What's below it?
These.
Oh. Perfect square below 12.
Or 4.
1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16.
Oh, so we say.
So, yeah, square root of 9 is below it, and above it is the square root of 16. So if you have a hard time with those squares, you might want to just list them across the top of your page while you do this assignment. All right, so we've listed them. Square root of 9 is 3, square root of 16 is 4, so I know it's going to be 3 point something. Now it's our job to figure out 3 point what. What do I got to do to figure out that fraction of the distance between them? What do I got to do first? Jack?
You do 9, or 12 minus 9.
Good, and you get
3.
3.
And then do 12 minus 16.
You want to know the whole distance,
Ooh. So then you get 16.
which is 16 minus 7. 7. 7. So my answer is going to come from 3 and 3/7. Because 12 is 3/7 of the way between 9 and 16. Right? All right. Now it's our fun job to change this to a decimal.
Yay.
So you gotta,
Wait, what is it?
what, Peyton?
Wait, why is it not 12? Wait, 12 and 67?
Because what's the square root of 9? Yeah, okay. All right, so 3/7, what fraction are you going to say that's pretty close to? Nathan?
4 is or 1/2.
4/8 or 1/2? All right, so And as a decimal, that's easy, 3.5. Check it on your calculator and see how we did.
Oh, it's 3.4.
Rounding it to the nearest tenth,
3.5.
3.5 to the nearest tenth.
Boom. It's not even on the six.
Questions about the process? Jillian?
Do you need to write calculator down every time? Like, what the...
On your homework, you have to do 4, I think, and the problem 5, I say go back and see for each, so next to it, yeah, you're right, where it actually was. All right, listen. Ultimately, this process we're trying to build in, you do it in your head ultimately, but as we do this at the beginning, we want you to go through the steps so that you're really thinking about it. But ultimately, when you look at one of these, you should be going through this process in your head, all right? Okay, so now I want you and your partner to, without my guidance, talk through doing the square root of 110 together.
The bottom of the